Hello, my dear lovely viewers. Welcome back to my channel. I have an interesting challenge today. We are going to look at this weird-looking exponential equation. We have here 3 multiply s raised to the power of log of the argument 2 divided by log of the argument 5 plus 2 raised to the power of log of the argument x upon log of the argument 5. Everything equal to 64. The reason why this problem is dreadful is because of the fact that we have logarithms in their exponents. And we can actually simplify that by using the change of base property. So if we have log to the base of a of the argument b, I can decide to change the base of this log to any base of my choosing. If I change it to the base of y, we are going to be having log to the base of y of the argument b upon log to the base of y of the argument a. So this first guy here, log of the argument 2 upon log of the argument 5. Now, because the base is not written, these logarithms are actually in base 10, or what we call common logarithm. If I use the change of base property, I can put a reversibility sign here. This is going to become log of the base 5 of the argument 2. I think this makes sense to common reasoning. So if you were to convert log of the base 5 of the argument 2 to base 10, that would have become log of base 10 of the argument 2 divided by log of base 10 of the argument 5. So we are in order. Similarly, log of the argument x divided by log of the argument 5. Remember, the base is still the same, which is 10. We can also reverse this as log to the base of 5 of the argument x if we reason in this same line. So we move this scary looking equation. I can rewrite it as 3s raised to the power of log to base 5 of the argument 2 plus 2 raised to the power of log to base 5 of the argument x equal to 64. At least we have done well by refining the context of this problem. The next thing we shall do again is to find a way to take care of these two because of the fact that we have a base 5. There's also a property of logarithm that says that if I have a number a raised to the logarithm of the same base a, this is equal to 1. If I were to have an argument or antilog, I would say a raised to log to the base of a of the antilog or argument b, this is equal to b. This is because of the fact that a raised to log of a is actually 1. So I can write 2 as 5 raised to the power of log to base 5 of the argument 2. Knowing fully well that 5 is an exponential, logarithm to base 5 is the inverse mathematical operation that we cancel out to give 1. So in place of 2, I will substitute 5 raised to log to base 5 of the argument 2. So I will then rewrite this equation as 3s raised to the power of log to base 5 of the argument 2 plus 5. In place of 2, I'm writing this log to base 5 of the argument 2 raised to the power of log to base 5 of the argument x, everything equal to 64. Now, this is where creativity has to come in again. I have log to base 5 of the argument 2 locked in here, then I have log to base 5 of the argument 2 here. So I want to interchange this exponent. I can only do so by using the fact that if I have a raised to the power of x or raised to the power of y, it's something as a to the power of sy. This is the power rule of exponents. So this can be written as a to the power of y raised to the power of x. What I've done is just to change the commutation. So with this, I can rewrite this. we are now going to be having 3s raised to log to base 5 of the argument 2 plus, here we are going to be having 5. I want to bring log to base 5 of the argument s inside the exponent. I'll now have log to base 5 of the argument s raised to the power of log to base 5 of the argument 2. We are going to be having everything equal to 64. So, if you look very carefully, that's the beauty in mathematics. You can see 5, we annihilate log to base 5. That's going to be 1. So we can rewrite this equation as 3s to the power of log to base 5 of the argument 2 plus x raised to log to base 5 of the argument 2, everything equal to 64. At least the problem is a lot easier to treat now. I have 3 of s raised to log to base 5 of the argument 2. I have 1 of s raised to log to base 5 of the argument 2. They are actually like terms which can be added together. 4s raised to log to base 5 of the argument 2 equal to 64. Now I can divide both sides by 4. This is going to give me s raised to log to base 5 of the argument 2 equal to 16. 64 divided by 4, that's 16. Because the exponent here, s raised to power log to base 5 of the argument 2, I will need to also think creatively again on how we can deal with this log to base 5. So we shall take log to base 5 on both sides. So we shall then have log to base 5 of this expression here, s raised to log to base 5 of the argument 2 equal to log to base 5 of the argument 16. Now from the power rule of logarithm, we know that if we have a log of the base a, say b, to the power of m, this can be written as m multiply log to base a of b. So you can see that x is the one carrying this exponent. We have log to base 5, s raised to power of log to base 5 of the argument 2. Log to base 5 of the argument 2 becomes the exponent, so it can multiply. So we now have log to base 5 of the argument 2 multiply log to base 5 of the argument x, everything equal to log to base 5 of the argument 16. So we made progress. What we shall do, because of the fact that we are looking for the value of x, we can divide both sides by log to base 5 of the argument 2. So we are going to be having log to base 5 of the argument x equal to log to base 5 of the argument 16 divided by log to base 5 of the argument 2. And by the change of base property, this is simply log to base 2 of the argument 16. This is not a rocket science, very basic. So we can rewrite this equation as log to base 5 of the argument x equal to log to base 2 of the argument 16. Now, 16 is 2 to the power of 4, or 2 to the 4th. So we shall have log to base 5 of the argument x equal to log to base 2 of the argument 2 to the 4th. Now, from the same power rule of logarithm, this can be written as 4 multiply log to base 2 of the argument 2. And log of the base of the same argument is 1. So log to base 2 of the argument 2 is 1. We shall have log to base 5 of the argument s equal to 4. 4 multiply 1. So if we convert this logarithmic equation into its exponential form, s is equal to 5 to the 4th, which is 625. And there is no need for me to test for any extraneous solutions. So to our audience, you can actually verify this. Thanks for watching. Please ensure you like this video, share with your friends and family and your colleagues, and subscribe to follow us for more. See you next time and stay blessed.